Hey, let's add an isValidChain function to our blockchain class to accomplish chain validation. So this function is going to return a true or false value depending on whether or not an incoming chain has followed the rules that we've set up for the actual blockchain. So to begin, head to the blockchain.test.js file. We're going to describe a new block of tests for a function called isValidChain. Notice that it's camel cased. Then we have our callback function as usual. So this is going to be quite a lengthy group of tests since we have quite a few rules to cover when it comes to validating a chain. So first, we need to describe a group of tests when the chain does not start with the Genesis block, because that violates the first rule where the chain needs to start with that Genesis block. For this situation, we're going to use a describe block, and we'll say when the chain does not start with the Genesis block, we're going to run a test. So we have our callback function here. And in this case, we want to make sure that the isValidChain function returns false. So we're going to stub that out as the one test in our case when the chain does not start with the Genesis block. So now we need to cover the opposite case. Well, in this case, when the chain does start with the Genesis block, so when the chain starts with the Genesis block, then it should be okay. And we'll also add the additional information that in this case, the chain does have multiple blocks. So we have our callback function as the second parameter to this describe as usual. Cool. So this actually doesn't fit, so I'm going to make the font size a little smaller. I'll make it 20. Hopefully that is still visible. And yep, it still fits on the screen. All right, now we have this situation where the chain does have a valid Genesis block and there are multiple blocks. But in this case, the chain could have an invalid block somewhere down the line. So there's two ways where the chain could have an invalid block. First, we'll describe the situation where a last hash reference has changed. So we'll say, and a last hash reference has changed. And then we'll have our callback for the second parameter. And in this situation, the overall isValidChain function should indeed return false. Next, the second case where a block could be invalid is if the hash field itself is incorrect due to some tampered with data. So either the timestamp or the data field could have been changed. And well, if this happens, the chain should be invalidated. So we're going to describe a situation where the chain contains a block with an invalid field. Nice. And likewise, we want this to return false. So we have our familiar it that says it returns false, and then our callback as well. Cool. And then finally, this leads us to the last case where the chain is just fine. So we'll describe this situation, and the chain does not contain any invalid blocks. And only in this case are we going to expect the isValidChain function to return true. So we'll say that it returns true. So make sure to have that described situation as well as that it test, which checks that the function returns true overall. All right, that covers all the cases. So now we can add the expect statements. First up, in the case where the chain does not start with the Genesis block, let's add a line that changes the first element in the blockchain.chain. So right in the it statement, we're going to say blockchain.chain0 is equal to something else. Let's make an object with a data field, and let's call this the fake Genesis block. How evil. And as a result, well, we'll expect that calling blockchain.isValidChain and then passing in a chain array, we're going to expect this to be false. Okay, note that we've now defined how the isValidChain function should be structured. It's going to be a static function. So actually, instead of calling isValidChain on the instance, we're going to call it on the blockchain class itself. And the parameter is going to be a chain array. So in this case, it's fitting to have this chain array as a single parameter rather than within an object. Because when you're calling isValidChain, you expect the input to be a chain. So we don't really need to wrap it within an object in this case. Cool, so that should cover the return false case when it doesn't start with the Genesis block. Now let's fill out the rest of these tests. First up, we get to the case where there's multiple blocks, and it should return false when the last hash reference has changed. So first up, let's add a bunch of blocks to the chain in the it block. We can do this with blockchain.addBlock. This takes in a map, so an object. In the first one, the data can be bears. Let's do this a couple more times. And then the second one, we can add beats. And the last one will be Battlestar Galactica. If you're an Office fan, hopefully you let out a smile or a little laugh. And then we'll mess up one of the blocks in this chain. So let's all of a sudden change the last hash reference of the item at position 2. And let's call this broken last hash. So the last hash reference is now not what was originally created within the add block function itself. And certainly we'd expect that if we called isValidChain on the blockchain.chain here, well, this would be false as well. So go ahead and copy the previous expect statement that is expecting isValidChain to be false and put it within this it statement as well, or rather this it function as well. Now, if you look at the overall structure between these two tests, you might notice a slight issue. Right now, each test is sharing one overall blockchain instance. So this could be an issue because the test where the chain does not start with the Genesis block will actually run first. And this modifies the blockchain.chain. This means that when we get to the next test, well, it's still going to have modified data for that first item in the chain because we already changed it within here. But in the test case, we want this Genesis block to be unmodified. We want it to have a valid Genesis block. So essentially, we want every test to have a fresh instance of the blockchain to test with. To fix this, we can refactor the blockchain constant all the way at the top of the tests. So at the top of the test, instead of sharing overall one blockchain instance, we can give each following test its own instance using a before each block. Before each test, we're going to reset the blockchain to a new instance. We'll say the blockchain is now a new instance of the blockchain class. Cool. And instead of requiring this, or rather declaring this as a constant, we need this to be a dynamic variable, so that way it can be reassigned. So we'll change it to a let blockchain. Cool. So once we have that, we should now have a fresh instance of the blockchain between each test. Nice. Now we can write a similar test for the block with an invalid field. We're going to need a bunch of blocks as well. So let's place that within the it function here. There we have a bunch of blocks, and we'll do something similar. This time, let's modify the chain field of that second block, or rather the block at item index 2. And let's say that this is some bad and evil data. All right. And again, we're going to expect this overall isValidChain function to be false in this case. So go ahead and copy that expect statement and paste it within here. Cool. This brings us to the last test in the isValidChain case. So again, we want to add all of these blocks when the chain is valid, so that way there's multiple blocks. And in this case, instead of expecting this to be false, well, we'll expect it to be true. So copy all of those added blocks and then copy the same expect statement, but make sure that it's expecting it to be true in this valid case where nothing has been modified. All right, cool. That completes all the tests. However, notice that we're duplicating a hefty chunk of code between each test where there's multiple blocks. So we can use the same before each strategy within this describe to make sure all of them have the same multiple blocks added to the test. So we can call before each within the describe that has the situation where there are multiple blocks. Let's take on all the code for adding the block and then paste that within the before each. Now we can delete that within every single function, so that way we don't have to recall and duplicate this hefty chunk of code. All right, very nice. That is looking a lot cleaner, and we've now followed the dry principle of coding. All right, nice. So make sure to save that file, and then you might have the test running in the background already. Otherwise, run npm run test in the CryptoChain project. And immediately we're gonna see a bunch of errors. We see a completely red suite, and isValidChain is not even a function yet. So let's address that with the isValidChain code next. As always, feel free to implement the isValidChain code yourself as a little challenge. Otherwise, if you want to move through the project at a quicker pace, well, just go right ahead to the actual coding logic for chain validation.